Hey there, Eggbach friends. I am working on some calculus problems. Since I didn't hear any specific problems from you, I picked a few that I thought might be a little bit tricky for you. So the first one I chose was number 3. It was an implicit differentiation problem. 3x squared minus 2xy plus 3y equals 1, and you're solving for dy dx. So this would be 6x, and then you've got a product rule in here, minus, so we've got an f here of 2x, f prime is 2, g is y, g prime is dy dx. So we've got 2y plus 2x dy dx, plus the derivative of 3y is 3 dy dx equals the derivative of 1 is 0. All right, so we'll distribute the negative sign and bring together the dy dx terms. Everything else can move to the other side. So here we go. We've got 6x minus 2y minus 2x dy dx plus 3 dy dx equals 0. That will give us negative 2x dy dx plus 3 dy dx equals 2y minus 6x. Factor out the dy dx. And then we'll divide by this guy. So dy dx equals 2y minus 6x over negative 2x plus 3. And they are asking for you to find when x equals 2. So if x equals 2, we've got to figure out what y is when x is equal to 2. So go ahead and go back to your original problem and find y. So we've got 3 x squared. So in this case it will be 4 because x is 2. So 3 times 4 minus 2 times 2, so that's another 4y plus 3y equals 1. So 12 minus y equals 1. Y equals 11. So when x is 2, y is 11, we'll plug those values into our implicit differentiation. So 2 times 11 minus 6 times 2 over negative 2 times 2 plus 3. And that's where you get negative 10. So that was number 3. Another problem I thought you might need is number 5. So I'll just do a couple here on this, and I'll do a short little video here, and then I'll probably make another one with some more problems on it. So number 5, you're looking at that graph, and you just need to find the areas of each of these pieces. So break it into a bunch of smaller pieces. So you've got a right triangle, then you'll have a rectangle or a square, and then another right triangle, and then you'll have another triangle here, or you can do 2 right triangles. So area here is 1/2 the base times the height for this guy. This guy is just base times height. This triangle is 1/2 base times height, and this triangle is 1/2 base times height. The height of this triangle is always perpendicular to the base. This is the base, this is the height. So hopefully that gives you the helpful hint you needed to solve that problem. Really wasn't calculus-y other than knowing that the area is, or that the integral is the area under the curve. The next one I thought you would like some help on is, I wanted you to skip number 10. Anything with particle motion on it, you can skip for now. I haven't done a lesson. I'm planning to do a separate lesson with particle motion. 13 was one that I thought you might like to have. So looking at number 13, you've got, it was a funny setup, but it gives you some information that kind of tells you what you need to do. If you read the words really carefully. So they say it's differentiable, which means it's continuous. This piecewise function is continuous. So if it's continuous, they have to meet at x equals 1. They have to connect there. So they're going to have the same output at x equals 1. So in order to find what their output is, you can set them equal to each other. So we've got 3ax squared plus 2bx plus 1 equals ax to the fourth minus 4bx squared minus 3x. And you set them equal to each other. And then they tell you find the values for the numbers you're looking for solving for b, but you're at x equals 1. So you can substitute 1 in for all of your x's. So that'll give you a 3a plus 2b plus 1 equals a minus 4b minus 3. And then combining like terms, you've got 2a plus 6b equals negative 4. All right, there's two unknowns, which means we're going to need to come up with another equation so that we have two equations. And so that means we've got to find the derivative now. It's differentiable, so we can do it. So the derivative of these guys, we've got 6ax plus 2b equals, that'll be 4ax cubed minus 8bx minus 3. And again, x equals 1, so we can plug in 1. So I've got a 6a plus 2b equals 4a minus 8b minus 3. And we can combine like terms again. So that's 2a plus 10b equals negative 3. So now we've got two equations and two unknowns, and this is just your algebra elimination method. So 2a, I'm going to actually move that. Let's take our second equation, multiply it by negative 1. So I've got negative 2a minus 6b equals 4. And then we've got 4b equals 1, so b equals 1/4. All right, I'll do a couple more in the next video. I don't want to make this too particularly